Alright guys, so we are taking a look at this homework video for geometric and exponential graphing. Okay, so we're just basically going over the problems, not really doing a ton of explaining. If you need more help with that, not sure what to do, go check out the notes video on this same topic and you'll be able to get a lot more information. I'd suggest watching that one first, doing your homework, and kind of using this to check your work. Okay, so let's go. So the first one, we're just graphing with a table. So each of these are points, right? So I'd go to -1 up to about 2.5, about right there. And 0, 5 would be right here, our second point. Then 110, and finally 220, okay? Then remember, we have to determine if it's discrete or continuous. Being that we see x's and y's, generally that means it's continuous. We also have to remember we don't see anything that would indicate we're shifting up here. So most likely we have our asymptote, that invisible barrier, down there on the x-axis. So I'm going to start clear down there, and I'm going to connect my dots, draw arrows, and that's all we got to do. Okay, so number 2, again, we're kind of just assuming that our asymptote is right there. Then we're going to graph it. So -2 to 16, right there. -1 to 8, right here. 0, 4. 1, 2. 2, 1. And again, we can see that it would start up here high, and it would come down and pretty much get really close to that asymptote. And it would look something like that, okay? All right, so that's really all there is to it. Now, if we look at 3 and 4, we should know right off the bat, since they're recursive, that these are going to be discrete, okay? Which means we only draw what we see, which is the points. A sub 0 would be our start, and we're times them by 3, so every time we go to the right one, I'm going to times my y value by 3. So 2 times 3 is 6, 6 times 3 is 18, and that's pretty much all I need to put for right now. If I really wanted to, I could go back and divide by 2 by 3, you get like 2/3 right there. That's pretty much all I got to do. Okay, same with number 4. Start at 20. Now I'm dividing by 2, so as I move to the right one, I'm going to divide by 2. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 2 is 2.5. 2.5 divided by 2 is 1.125. Okay, so it looks something like that. So those ones are pretty easy because we don't draw the lines, we just draw the dots. Notice we have a growth function here as well as a decay one. Okay, decay going down in this direction, growth going up in that direction. Okay, all right, now we've still got that, and this should actually be explicit. Apparently I copied and pasted, forgot to change the word as I did the equation. We're still in that sequence notation format, okay, but it's more like that a times b to the x style, where a is our y-intercept, our start, b is that rate of change growth there, okay. So start at 1 here, so go up to 1, timesing by 4 each time. So as I move right 1, we times by 4. So move to the right one, times them by 4 again, and that's pretty much all we've got going on here. So if we wanted to, we could move backwards and I'd divide by 4 if I really wanted to kind of get that same setup going on, okay? But that's really all there is to it on these simple ones. Now number 6, we start at 18, timesing by 1/3, which is the same as dividing by 3, right? Which may be easier for some people to think of. So 18, I move to the right one. 18 divided by 3 is 6. 6 divided by 3 is 2. 2 divided by 3 would be 2/3. Divided by 3 would 2/9. It would just get really close to that asymptote, right, on the x-axis. Okay? All right. So looking at number 7, 8, 9, and 10. Now we see that y equals and that, so these ones are definitely going to be continuous, okay? But same idea. We start at 2 here. We're timesing by 2 each time, okay? So as I go to the right, we're going to multiply by 2. So 2 times 2 is 4. 4 times 2 is 8. Notice I'm moving to the right on the x's. 8 times 2 is 16. And then 16 times 2 is 32, so I'm kind of out of luck on that side. There's no shifting of this up or down, so we definitely have our asymptote here. Okay. And then if I were to go backwards, we would divide by 2, right? So 2 divided by 2 would be 1, which is counting by ones. 1 divided by 2 would be a half. So we can see I'd start really close to that asymptote, and then we shoot up just like that. Okay. Make sure that when you graph the side that's going by the asymptote, that you kind of flatten it out, okay, instead of making it go across. Same with number 8. There's no shifting, so my asymptote is going to be right here. Okay. Then we start at 24 up here, timesing by a half, which is the same as dividing by 2. So as I move to the right 1, I go down half. Half of 12 would be 6, half of 6 would be 3, half of 3 would be 1.5. And so I can see I'm coming down like this, and I'm going to keep going in that direction. Okay. Now, if there happened to be a plus 2 or 3 or 4 or a minus here, that would basically shift the whole graph up. Say it was plus 2. We would shift our asymptote up 2, which would shift everything else up 2. Okay? And it would basically, just make everything else shift up. So it's kind of like we have this parallel line. And I didn't draw my first line very well to make it look that great. But and if it was down, everything would just shift down to whatever it was. And all these points would shift down that same way, and it's kind of like you're just making a parallel one. Okay, the thing is, it just changes some of your other pieces, so that's just something to kind of pay attention to, even though we didn't really do that on this homework, okay? All right, so number 9, no shifting. Same with number 10, so our asymptotes are definitely there on the x-axis. Okay, so we start at 4. Which would be about right here. Notice we're counting by 5s, and we're timesing by 3, meaning on our scale we're counting by 5. So we're going to kind of just do the best we can to estimate. So 4 times 3 would be 12. 12 times 3 would be 36. So I'm still only moving to the right 1 each time. 36 times 3 would be like 100 and something, so that would be like clear up there, probably even further than that. And so I'm going to start low, jump up there, and then just really kick it up high. Okay. Number 10, start at 64 right up here, timesing by 1/4. That's the same as dividing by 4. So 64 divided by 4 is 16. So we jump down to 16 really quick. 16 divided by 4 is 4. 4 divided by 4 is 1. Then 1/4. So we're starting up high again. Just getting really quickly, really low, getting to that asymptote. Okay, that's really all there is to it. So, yeah, there we go, guys. Hopefully this video, the sound was better. I'm not using that program that I used before, so hopefully the voice is keeping up with everything else.